Good morning from Germany. Good morning to America, because you have has 11 o'clock here. We have 5 o'clock in the afternoon, and I like to show you our product range and to give this presentation with our new partner DMA. So EXAFlow is a German company, and we are about 50 kilometers south to Frankfurt am Main. So that's easy to travel because the airport is close to our home. So how it started, it was in 1999, as we started with carved tunnel gate inserts. And at the start, we produced them by milling, turning, drilling the thread, hardening, ground at the end, and the curved tunnel was eroded via EDM. So we started with inserts made by milling, turning, drilling, hardening, ground. At the end, the curved tunnel was eroded via EDM machine per C-axis. Okay, so in year 2000, we built this mold, and we heard about this process to make metal parts by MIM. That means metal injection molding. And so it was a bit risky. We built this mold because it was a new technology. And you can see here a hydraulic cylinder, and this hydraulic cylinder move a rotating slider. And this was how we started. Can you see now page number 6?
Yes.
Okay, it's now working to share my monitor.
Perfect.
Great.
Thank you.
So here you can, you're welcome. Here now you can see the mold we designed, and our mold maker was a bit skeptical because the process is that you first go on a injection molding machine, produce a green part. It's called a green part, but it's gray, and it is the metal powder with binder, and later on, after sintering and debindering, it looks completely different. So that was new for him. So this is the finished mold, high precision. And as you can see, 2 sliders touch each other. Here now you can see the material we are producing our inserts. It's from BASF in Germany. The material is called Cutter Mold 420W. It's X20 Chrome 13, and it's a hard-able stainless steel. That's great to have a hard-able stainless steel. The hardness is 50 plus 5 Rockwell C. The density is 7.6 gram, and it's high wear resistant. And that is true. We see it if we put the thread in, and we see it how long our products last at our customers. And it started in the right picture with such pieces from granulate from BASF. The process then needs a catalytic debindering oven, chemical catalytic debindering oven. After this process, we called it a brown part. And then you put the brown part into the sinter oven, and the temperature is about 1350 degrees Celsius. So we are on the market since 1999, and during this time we developed different types of curved tunnel gate inserts. The very new one is on the left top, called EXAFlow GRF5. And now I will explain the different inserts, for what they are and how for what you have to care about it. So benefit from our product, the advantages are perfect surface quality and concealed gate marks through tunnel gating, even on rear molding wall, thanks to innovative EXAFlow technology. That means that is a circle 3/4, so you can inject at the rear side of a plastic part. The gate diameters are variable from 0.5 to 3.5 millimeters, so you can produce lightweight plastic parts or medium or heavy parts, and you have the possibility to design or to create the gate diameter itself. Also a clearly defined separating edge for precise degating is one key point. Customers save time and cost through fast and easy interchangeability. That means we have the parts on stock, and if you need some more, you can have it within 1 or 2 days, and you have not to manufacture by itself. These MIM material are high wear resistance, and these inserts are made in a single part design. That means we have compact dimensions. Here now you see the overview from we called it the standard products. Standard products are for flat plastic parts, where the parting plane is flat, is on the ejector side. And so we have different versions in round, in diameter 10, 12, and 14. And we have the same as rectangular inserts, also with dimension 10 millimeter, 12 millimeter, and 14 millimeter. And the picture right on the bottom shows our EXAFlow, the smallest one, 5 millimeter to 10 millimeter dimensions. Is the presentation now working? Can you see page number 14?
Yes.
Benefits from our standard inserts. Very good. Alles gut. The small one, the GTM inserts, is for tunnel gating of small thin-walled moldings. This gate insert possesses no calotte and therefore suitable for very thin-walled moldings. I remember parts with 0.5, 0.4 millimeter wall thickness, and this is really thin. Available gate diameters from 0.5 to 1.1 millimeter. Usable for all thermoplastic, including fillers, up to 50% glass fiber. And then it will last a lifetime, I can say, because of the material. The GTR and GTE inserts for tunnel gating of small or to medium-sized moldings along a flat separating plane. The projecting calotte ensures concealed degating. I will explain this later. It's also a thing EXAFlow recommended, and you can see it at our inserts, and most customers work a bit different to us. Available gate diameters from 0.8 to 2.4 millimeter, and also these inserts are usable for thermoplastic plastics, including fillers up to 50% glass fiber. Here you see the GTR10, and we have a chart here to help the designers and the mold makers also, where you can see how the diameter of the gate has to be. So we grouped plastics into 3 groups: high flowability, regular flowability, or poor flowability. So you have to know which plastic you have, and then you can choose from a list. So first you look what plastic you have. So maybe here regular flowability. The next thing you have to know is the weight of the part in gram. Maybe, for example, here 16 gram. Then you have to choose a GTR 1012. That means the dimension 2, D2, is 1.2 millimeters. And the steps are in 0.2 millimeters. So we started with 0.8, with 1, 1.2, 1.4, 1.6. And so we are flexible if you have a multi-cavity mold and they have different weight, so you can choose from this product range. The diameter is 1.2, and here left on the picture, left bottom, you see where the defined breaking edge is. There's this thing we called calotte or dome, and the height is 0.8 millimeters, and at 0.4 millimeters, just go back, there is this defined edge where runner and part split into halves. So you have an automatic degating and separate runner from part. Here now you see the 3 different sizes for the rectangular version. So the curve itself, the curve tunnel, is absolutely the same, but it's in this version. Some customer ask why you have it in round and why you have it in a rectangular version. So we sell 50-50 of them. In some cases, it's good to just drill a hole, and in some cases, maybe there's an insert and the insert is flat, then it's better to install a GTE. This is a typical installation, how you install in your mold. So it's a flat part. You see here the insert, the runner, and the ejector. The front of the gate insert is sealed off by the mold cavity. We see it in the right picture, to reduce pressure loss and to avoid jetting. You can also install our inserts at the nozzle side, and the gate insert screwed into the nozzle side of the mold. The front of the gate insert is sealed off by the cavity, also to reduce pressure loss, to minimize shear. This is our also new, about 2 years ago, GTM closed gate diameter for small, thin walled moldings, 5 to 10 millimeters in size. And here is an installation example for really thin parts. And as you can see, there's no calotte, because for such small gate diameters, it's not needed. Here's a chart, and this chart is also very helpful for the designers and for the mold makers to know where the ejector position is and the runner diameter, and also important is this dimension AT. So we grouped into 3 different plastic types. That means soft, medium hard, or brittle, and also the elastomers, rubber-like plastics. And as you can see, for a GTR or GTE, we need 20 millimeters only. That's not much for the dimension L, and for AT 16 millimeters. That's for soft materials, and for medium hard materials we have here 25 millimeters and AT 20. So as we started, we built a mold, a testing mold, and we tested it by a movable ejector. That was a clever mold, and then we saw that these values, these dimensions really work. Here's an animation with GTE or GTR. So you put EXAFlow insert in, you assemble the tunnel gate and insert with a screw. All sharp edges, round. Ejector depth, the length to the ejector, AT and L. So now the mold fills up. And now comes the degating. We need a flexible, a bend-able plastic. That is important. So here you see now the list of our contourable inserts. They all have names: MaxiFlow, MIDIFlow, ContourFlow, RingleFlow, because I, as a developer and inventor, I see this not only as a piece of steel. So I see this like a kind of children, and I'm proud how they work and how they save money for customers and avoid problems. This was our first contourable insert, ContourFlow GTK, and it is the most successful product we have in our program. And on the left side at the bottom, you see diameter 2 millimeter. That is a spherical geometry in the gate area, and it permits skating on inclined or curved surfaces. So if you have a sphere and you cut it, then you have a perfect circle. And this is unique for EXAFlow. And it's easy for the designer to find the right position and to find the position to place the gate. So here is a installation example how to use our GTK ContourFlow. So you place it at your plastic part and you transfer the parting plane, contour it, rework the runner, then machine the gate itself, and then the result has to look like here. Clean degating point without projection. That is nice. So we have some companies, they produce children toys, and children take plastic parts in their mouth so they can damage the lips or something else, and this is avoided by to use a calotte like this. This is a example for rubber-like plastics. To produce rubber-like plastics, we recommend a center cone at the ejector and a minimized distance depending on the shore hardness of the rubber-like plastic. And then it will also work. And this is the new product, brand new. It's hot, we can say. It's called EXAFlow GRF5, and it needs a bit to tell the customer that such a product really can work. It's made out of one piece, so no two halves where steam and dirt can go into the two halves. And if you produce white plastic parts, you see dark clouds at the plastic parts. And but it's a bit tricky to manufacture such a product like this. But for the customer, it's so great to have such a solution. And here we have also the diameter 2 millimeter to find the perfect position for the gate. It's 20 to 8 millimeters and 22 millimeters in height. Runner is 5 millimeter here. And the first inserts are working now, and I'm proud that they work so great. So for best operating, our EXAFlow needs 2 ejectors. So we called the second ejector a supporting ejector, and it's really needed. So you can contour the ejector, the supporting ejector, or it can be also flat. The runner has to be a bit bigger than the curved tunnel itself, and a good round, no sharp edges, then it will work very nice. So here now is an animation to see how this support ejector work. So it makes that 2 ejectors hold it in horizontal. And so the bend point is at the support ejector. We need for this a bend-able plastic. So 50% glass fiber or very brittle plastic types cannot work with this product. So this now is our EXAFlow range. We have 3 different curved tunnels. So that means the outer dimensions are 30 to 12 millimeters, but inside the curved tunnel is different. And so the version 1, I have extra slides for it. So I will show. This is version number 1. And so you can inject 10 millimeters above the parting plane. And this product range, the GXK1, the EXAFlow, they need also a support ejector. Number 2 is 8 millimeters below the parting plane. You can do products like this. And number 3 is 10 millimeters below the parting plane. So here you see now the GXK2 with 2 ejectors and also the sense for the support ejector. And here you see the support ejector is not contoured by the runner, it's flat. Very nice and gives us a lot of possibilities for different plastic parts for different applications. We recommend, if you have 2 cavities in opposite position, to install 2 ejectors over the middle. And then the degating will look like in this animation. So the 2 ejectors hold it horizontal, and then they can move out at the 2 curved tunnel gates without problem. Otherwise, and we saw it often, if customers place only 1 ejector in the center, it could be that it stick in one side. I remember cases we placed the left EXAFlow into the right position, and it was the same, and we solved the problem with 2 ejectors over the middle. This is what we recommend, and that the mold will work. Here's another chart for our customers to place the ejector L and AT. And as you can see, for soft plastics, we have 35 millimeters. For L and AT, also 35. For medium hard plastic, it's 40 millimeters. And if you have brittle plastics, so please ask us on request. Because of the 3 different shapes we have with the EXAFlow, sometimes some customers choose the wrong version. And so I created a slide, animation to explain that they should consider the effective curve length. So if you have a part with 1 millimeter wall thickness, GXK1 is not the clever version. It's as you can see, the curve length, GXK3 then is the right product for you, because the curve length is the shortest. There's another product range, we called it EXAFlow, because for parts with gate size up to 1.8 millimeters, part weight up to 300 gram, runner diameter 8 millimeter, and these inserts are contourable up to 8 millimeters. We see the 3 different shapes, the same system as the EXAFlow, a bit smaller. So this is version number 1, up to 8 millimeters above the parting plane. Also here the spherical geometry in the gate area. Number 2, up to 5 millimeter below the parting plane. And number 3, this is our most successful, or maybe the applications mostly look like this here, is up to 8 millimeters below the parting plane and spherical geometry at the gate area. This is unique for EXAFlow inserts. Here is the chart for the MIDI-flow. You see same thing. The plastic are grouped in soft, normal, rubber-like or brittle plastics, and you see L and AT in this chart, and this will work. If you follow our recommendation, this will work. So we need this extra ejector or support ejector for the Ringle flow, for the Maxi flow, and for the MIDI flow. One thing I'm a bit behind that customer makes it like recommended here is to contour our inserts with a calotte or with a dome. And here's the instruction for it. And the result should look like in the picture in red, left bottom, calotte on molded product, so that the breaking line is 0.3 to 0.5 millimeter inside of the wall thickness. So if you assemble different plastic parts or electronic parts or something, so there is no overstanding plastic particle. This is a table of viscosity. So you see 3 different curves in blue, in red, and in black. And low viscosity is black, medium viscosity is red, and high viscosity is blue. And so this is a house number for the designer. So if he know his part is maybe 40 gram and the plastic has medium viscosity, he can look at the red curve, and at 40 we need a diameter, gate diameter from 1.8 millimeter. It depends a bit if you have windows, if you have ribs or something else. And so, but we support our customers. They can ask us and send the plastic parts and so on, the 3D cut files. For heavyweight plastic parts, there's a other table of viscosity. And as you can see, for a 500 gram part, the red line for medium viscosity, we need about 3.4 millimeter. So this is too much for one insert. That means you have to place 2 inserts then. EXAFlow Masters filled plastics. This is about 4 months ago. An Italian customer want to use a material Riamax HR with glass fiber 30% and with flame retardant. And from the technical data sheet of the plastic, it looks like that this plastic is too brittle. But in reality, it was bendable and we produced it very good. He bought a lot of our inserts and is a happy customer. And we have a demo mold. And in this demo mold or testing mold, we had material from VTS Plastics. That's a German plastic manufacturer. And the support engineer was at our site and we did the tryout. They gave us 20 kilograms of the material and all involved people are happy because of this result. Solitech Rapid Tooling is 5 kilometers far from us, and we have a friendship with them. And so we have the possibility to test different plastic types if it's needed.
And there are a couple questions here in the chat. One question was, can we use them with PVC plastic?
PVC. Yes.
Yeah. Mm-hmm.
Yes.
And is there any limitations? Go ahead.
No, I know some customers, they are using PVC. We have this stainless steel. This is a big benefit from EXAFlow. And I think EXAFlow is unique for hardable stainless steel. For PVC, it's very important because the steam can make the steel that it will corrode. And the very special thing with PVC is the high temperature. But then the plastic is hot, the mold is hot, the temperature of the mold is hot, and then it works like a polycarbonate. So I have many customers, they are using PVC and have no fear if this material is in the application.
Okay, good. And then there's another question. Does it work with very low melt plastic? And in quotations, 0.3 MI.
What means this?
William put that in. William, would you like to?
I would assume that means the melt flow index.
Mm-hmm.
The melt flow index.
Yeah.
Oh, okay. If the melt flow index is very low, I have to look for the data sheet. The melt flow index mostly is not the problem. What we need is the E module and how bendable the plastic is.
Okay. And then another question, are you able to mold lens quality with this? So any type of polycarbonate?
Please, can you say it again?
Lens quality application. So any type of
lens.
Yes.
Lens quality.
Mm-hmm.
I must say that for such applications, we need experts. So if we as EXAFlow and the customer are experts, we can also produce lens typed plastic types. There is one thing, air bubbles inside. So I know my job now very long. I'm very experienced, and I was also mold maker, and I worked with the tool setter from the injection molding machine. Rounds are very important, and to bring the air out, so air suction or something else. So it depends not on our EXAFlow products. It depends on how experienced all parties of such a project, such a application are.
Okay. And then there's a question here about runners getting stuck. Do you have any tips or best practices for when the runner gets stuck, or what conditions inhibit that situation? So what's the solution?
Yeah, it could be if customers run a hot runner and maybe the material was long in the nozzles, then you can damage the material. Then it is very brittle after 1 hour or more. And but our inserts are so conical from the shape that you can move them out. One trick is heat them up a bit and give air pressure at the gate, directly at the gate. The next is a special screw. You use it for wood, I guess. And so heat it up with a burner, screw it in, and then you can move the runner out.
Mm-hmm. Okay. Another question is, do you offer any solutions mounted from the parting line?
Yes. Yes, we have a solution on YouTube. I will have. Can I start it?
Sure. Yes.
Okay. here is, if you can see the video now, this is a solution how to fix it, and you can disassemble from the parting from the nozzle side or from the ejector side. But okay, should we stop?
There's a couple other questions we could probably take care of real quickly. How about high heat concentration at the gate area? Is there any issues with too much heat at the gating area? Maybe some type of part blemish or anything like that?
Yes, yes, we know this, and it's a recommendation to avoid the shiny spot or and the rough spot opposite to where we inject, and it has to do with cooling. So you need cooling holes. I have recommendation for it how to avoid such problems. So you need special cooling holes around or close to our EXAFlow insert, and maybe opposite where the gate is. And so you can produce high gloss piano, what is the name for piano paint plastic types, and we have a lot of experience with such parts.
Okay. And then this is risk of thin steel at gate location. I think the one that you just answered in this question, we can help you with if you provide us with your application. Our engineers at DME can work with Wilford, and we can make some suggestions so that we're not running into these type of issues with the cooling and any thin steel gate location areas, and help you out with that. And I think as you utilize these products, you'll become more and more familiar, and we're more than happy to take a look at your applications and help you out with the design, placement, and review the cooling with you as well. So not a problem. So these questions can be sent to dme_mechengineering@dme.net, and we'll put these out for you guys to be able to easily access the email address. We also have information on our website at dme.net on where you can download your CAD data, and there's also a e-store location where you can make purchases and find out more information as well on our DME e-store. So thank you everyone for joining. If they have any other questions, feel free to forward it to those email addresses, and we'll be happy to address them. Thanks for your time today.